Okay, our problem is 461. The bevel gear is subjected to the force F, which is caused from contact with another gear. Determine the moment of this force about the y-axis of the gear shaft. Now we have the bevel gear. We have two bearings here fixed to the shaft and well, fixed to the bevel gear and supports the shaft. The axis of the shaft is given as y-axis. X and Z axes are perpendicular to the shaft. Now we are given a force. The force is 20I, 8J and minus 15K vector, and the unit is in newtons. The distance between the force and the z-axis is given as 40 millimeters. Therefore, its x coordinate is 0.04 minus 0.04, and it has a z-axis of 0.03 meters. Okay, now we are asked for the moment along the shaft axis. So what we need to do is first we will write the position vector of this force, and then we will calculate the moment. Of course, the position vector is minus 0.04 I vector plus 0.03 K vector. Now next thing is to calculate the moment. Of course, moment is vector product of position vector with force vector, and we are already given the force vector as well. It is 20I, 8J and minus 15K. Now we will multiply each term one by one. First we will multiply this term with this term. I multiplied by I is 0, so this doesn't have any contribution. Now next is multiplying this term with the second term in the force vector. So 0.04 minus 0.04 multiplied by 8 will give us minus 0.32, and if I put my elbow on the x-axis and curl my fingers towards the y, my thumb will show me the positive z-axis. Therefore it is positive k minus 0.032 k vector. Now next thing is multiplying I with the k vector. So again 0.04 minus 0.04 multiplied by 1.5 will give me 0.06, and certainly from I to Z will give me negative y direction. My thumb will show me the negative y direction. As a result, it is minus 0.06 j vector. Now we are done with the first term in the position vector. Now let's do the same thing for the second term. Again, we have 0.03 k vector. We will multiply it with the I vector. So 0.03 multiplied by 20 will give us 0.6, and multiplying k with I, so my thumb will show me the positive y direction. As a result, this is positive, so it is 0.6 j. Now my second multiplication is with 0.03 k vector with 8 j vector. Now if I put your elbow on the z-axis and curl your fingers towards the y-axis, it will show you negative x direction. Your thumb will show you the negative I direction, and 0.03 multiplied by 8 will give you 0.24. As a result, it is minus 0.24 I vector. In fact, multiplying k vector with k will give you 0, and it doesn't have any contribution. Now let's continue. We will sum up all the terms. So we have only one term on the x-axis. It is minus 0.24. It's here. Now let's look at the j component. We have 0.6 here, and we have minus 0.06, and it makes 0.54. Therefore the y component of the force moment is 0.54, and at the end we have the z component of the moment. We have just minus 0.32. As a result, we have minus 0.32 k vector, and therefore our moment vector is minus 0.24 I vector, 0.54 j vector, and minus 0.32 k vector. We are asked for the y component of the moment vector, and therefore our answer is 0.54 Newton meters.